Okay.
This is Bohr models and electron configuration. Go ahead, Dan. Now, we've already looked at the Bohr model. And we looked at the idea of why does the Bohr model fall into the nucleus? Or why don't electrons fall into the nucleus? Why don't electrons fall into the nucleus?
It goes through it.
They have energy.
Stupid. Maybe I shouldn't come back. That's a fail. Do you want it?
There you go. All right. Why don't they don't fall in because they have energy? They're traveling around the nucleus in orbits, things we call orbitals. Now, his model said they move like planets. They were circular orbitals, and that there was a certain level of energy that separated each one. Go ahead and take the picture. So there's the picture: nucleus, electron, orbit, different energy levels. All right. Remember, when we put the from now on in your life, pretty much always, any PowerPoint you ever see is going to be online or digitally available to you. So when you're taking notes off of PowerPoint, you're not trying to write word for word what's on the slide. What you're trying to do is capture the ideas of what the teacher is expressing as key ideas and key points, right? Summing them up there. You should never just copy a PowerPoint because you're not going to remember what it really means. You're going to miss out the nuance of what's going on when the teacher speaks. So when you take notes in college, same idea. Focus on the big ideas because those are probably going to be the ones on the test, right? So you don't write word for word because then you miss what the teacher's saying. You can always come back at a later point and jot notes down word for word from the PowerPoint if it helps you learn. Now, nucleus, electron, orbits. Notice there's two different colors, orange, blue. That's our two energy levels that he's talking about, distinct energy levels. One lower, one farther out. Go ahead, Dan. Now, he postulated that. Okay. There's a fixed energy for each orbit. Keep going. Electrons cannot exist between orbits. Now, this is a tough one to understand, right? What he means is that if I'm on the ground, I'm at one energy level, right? If I'm on the ground, I'm on one energy level. But if I step up, I'm here, right? I could be here or here. I cannot be in the middle, right? I can't stay there. If I can't go all the way up to the next level, then I don't move, right? There are specific energy levels that they need to be at. Now, go ahead. And that the higher the energy level, the further away they are from the nucleus. We demonstrated that yesterday with the lanyard when we were swinging it around, and we said it took less energy to swing it close than far away. And how much you finish your notes? And that an atom with the maximum number of electrons in the outermost orbital energy level is stable or unreactive. And we know that now is which group on the periodic table?
Noble gases.
The noble gases. The noble gases have full energy levels, thus they are stable. And everybody wants to try and be like the noble gases. So his model helped us predict a lot of things. Go ahead. Now, how did he develop his theory? He used the idea of mathematics. He used a lot of mathematics, but what he was looking at was what spectrum was given off by different elements. Hydrogen was the element he studied the most. And we have to think back to what we learned about light and energy. What did we learn about light when we did Quest 9, I believe? Or 8. So 8 or model 1. What did we learn about light in Quest 8? We learned two different formulas. What did we learn? Whoop. Go ahead and hit pause on that.
Let's see here.
Hang on.